the question and patient will answer him with a voice. And C, different examination, once again, auscultation, but more than is different laboratory examination, or even such complicated examination like X-ray or even computed tomography. We also make the study in one university where took part also teachers, and teachers also highly appreciate the contribution of this technology in the educational process. That immersion can also train some skills in working with medical equipment, for example, with an ultrasound machine. Young doctors also understand a little of these gray spots on the screen. But however, the more times they see the real picture and correlate it with the sensor position, the better they will understand what they see. If needed, we can even hint at which organs they are currently looking at. Augmented reality. Augmented reality can be used to overlay important medical information on the real world directly with colleagues, even at the distance. In form of the avatar, doctors can discuss real patient data or see some training simulators, like you can see on the screen. In the surgeries, this technology helps in planning and conducting complex procedures. For example, with augmented reality glasses, a surgeon can see key patient data in real time during an operation, improving accuracy and reducing the likelihood of the complication. For example, I'm working with one of such application, I think 5 years ago, and indeed we see the good results for traumatological surgery. The time when surgeon used such technology, time of operation was less, and the incision was not so big like without this technology. But unfortunately, there is another question that surgeon is not always very useful to got this headset on his head, and we got the question with sterilization. But nowadays we got some miniature headsets and headsets that are available for sterilization in surgery conditions. Patient care. Virtual reality also has emerged as a powerful tool in healthcare, significantly reducing pain and anxiety during medical procedures for both children and adults by diverting attention away from the real world. Its effectiveness is evident in reducing the need of anesthesia, especially in children undergoing long interventions. This has been positively assessed by children, their parents, and medical staff. On these photos, you see our two examples. In the two cases was girls who were afraid doctors, but when in the virtual reality, they see some animated character who say them, open your mouth or raise a hand, the doctor can examine this child. Or in the case of the child who was afraid of vaccination, when she was in the virtual reality, she just made, oh, don't bother me, and without some screaming and without something difficulties. Virtual reality greatly aids in cases involving psychoneurological development. We work with therapists who treat children with autistic spectrum disorder or attention deficit hyperactivity disorder and other disorders. In the real world, it's very difficult to focus such children on performing a single task required during therapeutical session. However, when the child is placed in the controlled conditions in virtual reality, the situation changes and tasks begin to be fully completed. The methodology we developed helps to solidify the skills in real-world conditions. Thus, we observed such improvements as focus on the daily activities like reading, writing, drawing, and learning subjects, We saw the improved speech and objectification. Such childs got better spatial orientation, enhanced motor skills, and as general outcome, we saw the readiness of such kids to join school with less or even no support from companion teacher. And also some application, like you see on the screen, this crossroading application, help such childs to adapt to the conditions of the real world. Virtual and augmented reality are proving beneficial in treating psychological disorders like post-traumatic stress disorder and phobias by safely exposing patients to fear sources, aiding in overcoming and adopting them. These technologies not only make medical and rehabilitation process more engaging through gamification, but also promise to revolutionize medical practices and education, improving healthcare quality and accessibility. For example, even such primitive technology as augmented reality in the smartphone was evident in some researches that it's good for treating the phobias. For example, spider phobia and phobia of the dogs. Let's go. Next, robots. Nowadays, the interplay between artificial intelligence, machine learning, and deep learning ultimately leads to the working of robots in healthcare. Robotic technologies like Da Vinci system enhance surgical precision, flexibility, and control beyond traditional methods, even allowing remote operation. Surgeons can stitch with such robots very delicate tissues, such as grape's skin from across the globe. These robots are used for a range of different surgeries, including organ removal and hernia repairs, and such delicate operation like operation on the zone of head and neck. And this is the precision that was available 5 years ago. Recent advancements have introduced even more accurate tools, with some still under evaluation. And additionally, data from numerous of surgeries is training neural networks for potentially human-free operations in the future. For instance, the Smart Tissue Autonomous Robot, or STAR, has successfully performed laparoscopic surgeries on animal models, outperforming human surgeons in some cases. And this robot on an animal models already performed one of the complex operation connecting two ends of the intestine. Artificial intelligence further boosts these robots by aiding in decision-making and proving real-time procedural support. Okay, but in the healthcare, we got another robots, not only surgeons. For example, autonomous mobile robots. They are being used in medical facilities for tasks like disinfection and delivering the medications. Or we got some projects like Spring that aim to assist the elderly and reduce the medical staff workload. Also, some robotic exoskeletons nowadays improving rehabilitation by supporting mobility for injury or disease recovery. But industry specialists and futurists predict that in future, robots will become smaller and perform manipulations inside our body. Microscopic drug delivery systems are being developed that can nowadays transport drugs directly to specific disease tissues, minimize side effects on the healthy tissues, on the animal models. This approach is still in the early stage, but promises to enhance the efficiency and safety of drug treatments. For example, Bionaut Labs developed microrobots for precise drug delivery and to brain tumors, and to treating one of the syndrome by puncturing cysts that block the flow of cerebral fluid in the brain. These micro-robots can be made from synthetic or biological materials, or a combination of both, and many of them can be controlled externally using magnetic fields. Also, some of them can move autonomously. Or another example is the self-propelled robots for medical delivery to hard-to-reach places within the human body or animal body. Because during the research, a fleet of these micro-robots was used to transport doses of some medicine, dexamethasone, into the bladders of laboratory mice and demonstrating potential for treating bladder diseases and other conditions. Each robot measures only 20 micrometers wide. It's several times smaller than the width of the human hair. And nowadays, what we got? We got the primitive robotic systems as small as 20 micrometers, and they already can operate inside bodies. If we compare it with human cells in middle, it's 4 micrometers, what we can expect next? The size of such systems will decrease to the subcellular level, while their capabilities will increase. And that's why some futurists believe that futurologist believes that by mid of the 2030s, we will have medical nanobots that will allow us to make different things. For example, detect and eliminate most diseases at their earliest stages, or repair cells damage and malfunctions, slowing down the aging process, and even provides the possibility of significant extending human life. I will discuss this damage that we need to change in the second part of my lecture. Or perform the complex surgical procedures, or even replace our organs and tissues. However, this will be not the similar artificial organs, but rather the modification and enhancement of its functions. For example, specialized nanobots may be developed to extract oxygen from air and remove carbon dioxide, potentially replacing lung function, such as gas exchange and blood pH regulation. This simplification overlooks lungs. It overlooks, yes, complex roles of the lungs, but it highlights the potential for nanobot-based respiratory solutions. And such solutions nowadays described for any organ. The next thing is artificial intelligence. Currently, artificial intelligence is making its way into medicine just as in all other fields. Artificial intelligence is advancing in medicine, enhancing diagnostic by identifying patterns in medical data, including MRI, computer tomography scans, X-rays, and which improves early disease detections and diagnosis. For example, at this image, you can see computer tomography scan. On the red lever, you can see the green tumor, and the artificial, this neural network highlight its changes. Or these algorithms are already used in the computer tomography software and highlight some changes, and it is much easier for specialists to find these changes. Also, some startups are leveraging AI to analyze patient data, genetics, lifestyle, medical history, to tailor treatment plan as predict disease risk, or making a shift towards precision and personalized medicine, especially if these systems analyze non-stop incoming parameters, such as heart rate from the smartwatch, or in the future parameters from sensors that will be outside and inside our bodies, for example, to continuously monitor the content of various substances. Huge prospects are opening up in the discovery and development of drugs based on artificial intelligence. AI nowadays used to accelerate the drug discovery process by analyzing vast amounts of data to identify potential drug targets and model their effects. For example, AI helped discover inhibitors for the Alzheimer's-related protein base 1, leading to novel treatment approaches for this condition. Or take the example of the company in silica medicine, which utilized AI to discover a drug for pulmonary fibrosis and reached the clinical trials in 3 years since starting 2020. Because in the traditional way, traditional pharmacological way, we need 10 or 15 years before the clinical trials. Additionally, in the collaboration with the University of Toronto, they identified a liver cancer drug just in 30 days, and with clinical trial discussion in progress. And some companies like Gero now speaking that their systems in future can even found some anti-aging drug. Also, artificial intelligence is being utilized to develop an ideal human model, incorporating physiological and biochemical aspects. This could help to predict drug effects and explore anti-aging treatments. I'm by myself advising one startup on this project, and also I'm discussing with the New Jersey Institute of Technology Simulation Laboratory the creation of simplification model for training medical and bioengineering specialists. But some huge startups and companies going further. For example, a couple of weeks ago, French startup Bioptimus received funding to develop an universal AI model for biology, aiming to connect all biological scales from molecules to organisms through generative AI, with a commitment to open access and community engagement. And just 9 days ago, the neural network EVO1 was introduced. It's capable of generating and modeling DNA, RNA, and proteins, and even at the genome scale. Many believe that EVO1 will revolutionize disease treatment and gene creation, enabling rapid testing in simulations, freeing scientists from years of tedious work in laboratories. And with such neural nets, the creation and the extension of life is no longer since like science fiction. Oh. It's a very interesting topic nowadays, brain-computer interfaces and neural-computer interfaces. These such interfaces link the brain with computers, logical, and enhancing medical treatments, rehabilitations, and life quality itself. Brain-computer interfaces can read brain signals via electrodes, enabling control of device through thought and stimulating brain regions. Technologies vary from low-resolution electroencephalogram devices to precise implant sensors, which, despite their risk because they implant in the brain tissue, but they provide much more precise interaction with certain neuron groups. Other forms include the stent rod, which is advanced through vessels to the target brain areas without direct implantation in the brain tissue. And all these implants, all these interfaces are already used in people. Yes, many of them in experimental mode, but they are working. Neurocomputer interfaces support individuals with disabilities by restoring functions like movement, speech, and even sensory abilities, creating new brain external world communication pathways. For example, decades of years, we got some cochlear implants that returned hearing, while other interfaces simulate visual pathways for sight restoration. For example, alpha MAs and Argus 2. Additionally, neurocomputer interfaces treat neuropsychological and neurological disorders like depression, or post-traumatic stress disorder through brain activity modulation. We can use some methodic from transcranial magnetic stimulation, but interesting approach is deep brain stimulation. For example, for conditions like Parkinson's disease, where electrodes go in the brain, and it can reduce symptoms like tremor even in medical resistance patients. And of course, when we're speaking about brain-computer interfaces, we can't forget about Neuralink. Neuralink makes an advanced neurocomputer interface with thousands of electrodes. Previously, all systems in other companies made only with up to 100 electrodes, but in Neuralink it's thousands. And one of these systems is already had been implanted in the human for the first time. Previously, it was tested only on animals. And by the way, 2 years ago, there was a video of one monkey with implanted Neuralink, which can play in this Pong game only with the power of its minds, without some wires and other. 1 month ago, on January 29, it was revealed that a paralyzed volunteer nowadays successfully controlled a computer mouse and was acquiring new skills through thoughts alone. It was confirmed that the participant recovered with no brain damage or side effects. But truly, we should say that such cursor control via the implant, it isn't a new idea. It was first achieved in 1998, then furthered in 2004 with BrainGate company and their interface. And people with neural interface from BrainGate even enable TV control and object manipulation. And by 2018, two paralyzed peoples with a BrainGate can send emails one to other and use the tablet. But Neuralink novelty isn't in thought-controlled interfaces, but in its wireless chip, eliminating wires. Because in this image you can see the BrainGate neural interface with this huge thing on the head and huge wire, and only with 100 of electrodes. And Neuralink, you won't see these wires, but we will get the thousands of electrodes. And this is all just about reading information. Some specialists predict that the expansion of neuron detection could lead us to advanced neuroprothesis within decades. And if we will speak not about only reading information, we can think, what if through this high-density array of electrodes, we will start stimulating specific groups of neurons? For example, activating a certain group of neurons in the temporal area, and we will hear a specific sound or particular part of the postcentral gyrus, and we will feel some tactile sensations. And it will stimulate certain neurons in the visual area, and we will see something. Of course, initially there will be some flashes of light or something incoherent. But technologies will not stand still, and when humanity can stimulate certain neuron in the certain sequences, if you remember, I started talking about virtual reality in the beginning, and the convergence of virtual reality technologies with advanced full-fledged neural interfaces will allow us to create a completely experience with visual, tactile, auditory, and even emotional, that will be perceived and as a real. And futurists say that we will have such technologies in 15 years. Let's see. Okay, what I want to say also about these neuro things, neurointegration and machine learning are advancing limb prostheses that are thought-controlled and can mimic touch and temperature feeling. Some companies are developing closed-loop biomimetic neurorobotic prostheses with neuromorphic hardware. These prostheses have sensors in artificial skin to detect pressure, feeding data to a neuromorphic chip. This chip creates bio-inspired neural stimulation patterns and emulating natural somatosensory processing. Adjusting neurostimulation parameters and implanting neural interface channels produce natural activations in the residual nervous systems and making electrically evoked sensation both natural and informative for optimal sensory motor loop and that uses in prostheses. There are several of companies now working on such prostheses. And now we got the time to discuss bioengineering. By the way, in recent decades, biotechnology has made significant progress in understanding the process of aging and the possibilities of increasing lifespan. More importantly, humanity is now facing prospects not only of extending life, because few would want to be stuck forever in the old body of 100-year-old person, but also of altering our bodies about aging or rejuvenation. One moment, please. Okay, the significant recognition of aging as a condition in International Classification of Diseases 5 years ago marks a pivotal shift toward treating aging as a medically addressable issue. Officially, this opens new perspectives for researching aimed at understanding the mechanism of aging and developing effective strategies to combat age-related diseases. This recognition stimulates funding for research in gerontology and geriatrics and contributing to the development of new therapeutical approaches and medical interventions. Today, aging theories diverge into two paths. One view it as a genetically programmed process prioritizing early adulthood for reproductive success, while the other see it like an accumulation of damage or entropy over time affecting cells in the DNA. But by the way, a couple of months ago, there was another study, another publication that's showing the information theory of aging, and it's a pretty beautiful study because it links all these two theories together. Now I want to give you an example of the second theory, the accumulation of the damages. For example, from the earliest stages of our life, there can be some glucose pain cross-links between collagen fibers of our skin or vessels, but they are so few that they practically have no effects. But as the body grows, these cross-links accumulate. By the age of 40 or 50, 60, it's depending on your lifestyle. Many people have so many of these cross-links that the collagen fibers are more strongly bounded together and making the skin less elastic. More critically, our blood vessels become rigid, failing to handle with the pulse wave of blood, and it leads to the increased blood pressure, higher risks of atherosclerosis, and other so-called senile cardiovascular diseases. Again, collagen is present in many structures of our body, and everything gradually degrades. Other accumulations of damage lead to the emergence of other senile diseases, myasthenia, neurodegradation, and the general aging of the organism. This theory of damage accumulations give us the basis for developing anti-aging therapies. Let's look at the car analogy. Over the time, it rusts a little, runs out of brake fluid, and parts break. But if we will monitor the car and diagnose it delicately and in a timely manner, as well as replace parts that fail, then the car will be like a new. There are already cars that can be over 100 years old, but they still look and perform as new. So now let's return to the human body. This diagram you see represents the so-called hallmarks of aging, which indicate the primary candidates in aging theory that have been discovered. We will briefly examine the first level of detail and discuss what can be done about it. Stem cell depletion. It involves undifferentiated cells that can divide almost indefinitely. Initially, embryos are mostly stem cells, which then specialized as the organism develops. Aging is marked by reduced cell regeneration, and notably in the long-lived tissues like muscles and nerves. For example, over 80 years, the human brain loses a third of its cells and affecting the remaining tissues functions. Stem cells therapy or tissue engineering and organ bioprinting for transplantation are emerging solutions. Nowadays, the most well-known and regularly used cellular therapy in clinical practice is bone marrow transplantation. It allows for the creation of new blood and stem cells from transplanted stem cells, and it's really worked. And more importantly, this now it's feasible to transform any body cell, for example, skin cells. We can transform it to the stem cells, enabling the generation of specific cells like neurons that we can then implement in the same body. And since the cell originates from the same organism, such therapy does not require suppressing of the body immune response. Moreover, there is already the capability to fuel the 3D bioprinters with such stem cells, and not only stem cells, to print organs. Research have achieved success in the bioprinting various complex tissues, including skins, bones, cartilages, blood vessels, and even parts of organs like kidneys, liver, heart, thyroid gland. And these tissues show promise for use in the drug testing, disease modeling, and potentially even in future in transplantation. But by the way, some of the tissues and even thyroid gland that was made in the bioprinter was transplanted to the animal models. And the half of the transplantation was successful. Next theory is senescent cells or zombie cells. Our cells die in various ways, and this is a normal process. Some undergo programmed cell death known as apoptosis, among other methods, while the other can be destroyed by the immune systems. But aging is linked to the senescent cells, which halt division but avoid apoptosis, and translations into a state where they don't function properly but release inflammatory factors. This is cause inflammation, weakening the immune systems, and damaging nearby cells, spreading the senescence, similar how the zombies infect others. High senescent cell counts in the tissues is heightened cancer risk and chronic inflammation, undermining cell therapies in the elderly and exacerbation conditions like arthritis and osteoporosis. But nowadays we have senolytics. Senolytics is novel drugs designed to destroy senescent cells. They have shown the promising results in extending lifespan and improving health in animal studies, including the mice and dogs. Benefits observed include up to 30% increase in lifespan, enhanced cardiovascular, cognitive, and muscle functions, and slowdown in age-related diseases, and improvement in organ health and immune strength. Early human trials indicate senolytics are safe and may improve aging biomarkers, with the potential to treat idiopathic pulmonary fibrosis. But nowadays we need additional additional researches to understand the long-term effectiveness, because it's the newer drugs. Mitochondrial theory. Mitochondria is the cellular power station. They have their own DNA, mitochondrial DNA, but it's more damage-prone than nuclear DNA. Over time, a disruption in mitochondrial DNA disrupts its functions, and damaged mitochondria accumulate, it's naming the clonal expansion, and leading to cell dysfunction and increases the production of harmful oxidizing substances. Methods to combat this include the gene therapy to replace damaged mitochondrial DNA, or mitochondrial transfer from young to old cells for rejuvenation, and transferring mitochondrial genes to the nucleus for better protection. But all these methods is still in the early stages. It promises to rejuvenate mitochondrial function. We will see the results of such approach on the mice in the next year. Aging theories like disruptions in the proteostasis or nutrient sensing and intracellular communication to aging overlapping, it's overlapping with the theory of debris accumulation. For example, normally the cells managing damage or redundant components through the lysosomes or enzymes, recycling or expelling them. However, these substances can form the residing clumps, like lipofuscin. When it is deposited in the skin cells, it gives our tissue a specific coloration. I think you probably seen this in some individuals. But however, lipofuscin does not only accumulate in the skin cells. Liver cells, muscle cells, neurons. Over time, lipofuscin appears everywhere, occupying more and more space within the cell. Or another example, it's vitamin A derivative form. It can accumulate in the eye. It's leading to the blindness in elderly. Various strategies we got how to fight with these things. It includes the enzyme therapy and gene therapy to produce new enzymes that can manage these clumps. The enzyme therapy effectively removing this form of vitamin A from the eye, and it has already been developed and addressing this issue in the human, and clinical trials was successful. Discussing these extracellular debris, we focus on misfolded proteins like amyloids and tau. It causing amyloidosis and tauopathies. For example, beta amyloid known for forming plaques in the Alzheimer patients. It accumulates in everyone over time, yet not all develop the noticeable Alzheimer due to the varying rates and quantities of these accumulations. The K-ray research avenues include the immunotherapy, how passive to active, or targeting beta amyloid. Or nowadays also interesting researches on the small molecule inhibitors to block production of this amyloid, and experimental methods like gene therapy and CRISPR-Cas9 for therapeutic protein production or genetic risk modification. Additionally, as mentioned earlier, interprotein crosslinks, notably between collagen molecules, it affecting aging by reducing elasticity in organs, vessels, and skin. As I said, that glucose pain make up over 99% of these crosslinks. It leads to decreased elasticity and vascular stiffness, and contributing to heart issues. But about 9 years ago, Yale Spiegel laboratory synthesized artificial glucospine. It was enabling the discovery of 3 enzymes that break it down. This led to the founding of Revel Pharmaceuticals some years ago, which is developing a drug targeting glucospine cross-links and now approaching to human trials. And one of the last theories, it's genomic instability theory, which suggests that organisms lose the ability to repair damage to their DNA over time. Mistakes in reading DNA information can lead to various types of damage, including uncontrolled cell divisions or the development of cancer. It's not surprising that malignant tumors become more common with age, as this number of errors in genetic material increases. This is directly related to something very important and relevant today, the epigenomic theory. Let me try to explain in the simple terms. We have DNA, which is programmed on how patients work, how proteins work, and how all the processes acquire in our body. However, we have the same DNA in the skin cells, in the neurons, but somehow these cells behave completely differently. The reasons is that methyl group and some other changes are present on the different parts of the DNA in the different types of cells. And these changes is regulating the activity of the genes in the cells without changing the DNA sequences itself. It is that the epigenome is all about. These epigenetic marks influenced by environment and age, and dictate the gene expressions impacting cell functions and aging. Over time, epigenetic information lose alerts and lose cell identity and functions, leading to aging-related disorders, many of which I listed earlier. And this is the point where all the theories, genetic theory and damaging accumulation theory, are linked. And recent experiments show that epigenetic reprogramming using small molecules can reverse aging signs in human cells and in aged mice models, restoring youthful epigenetic states and cell functions without genetic modification. For example, in an aged mouse model, there were characteristics of physical and physiological changes, including alopecia, graying hair, kyphosis, decreased body mass, movement, and decreased respiratory exchange ratio. However, after the application of developed substance, it was possible to reprogram the epigenome, and these age-related changes were reversed. The mice fur become denser, the grayness disappeared, and the muscle frame strengthened, and behavior became more like that of young mice. And clinical trials of this approach on humans are planned to be conducted within the next 5 years. According to the various futurist prediction and startups who are working with this technology, by 2035, we will have working therapies for each of these issues I mentioned earlier, applicable to humans. And for some of these areas, clinical trials are expected to conclude in the next few years. Of course, this was a little bit somber. I quickly covered the main points that could transform healthcare and lead us to the radical extension of life. But each step, each slide, each piece of information I mentioned today deserves its own conference to understand it even more or less fully. But if you're interested in it, I can recommend you to familiarize yourself with this publication to understand all these biomarkers of aging. Or if you're interested in this topic, I also can recommend to explore these sites, because here you can find many actual information. And it's crucial to emphasize that the progress in many fields is possible thanks to an interdisciplinary approach that unites the efforts of professionals in medicine, biology, information technology, ethics, philosophy, engineering, and many other fields. Only through collaboration and knowledge exchange between different sciences disciplines, we can push the boundaries of what possible and move forward towards creating a healthier future for everyone. Thank you for your attention. I hope I don't bore you too much. And I hope the lecture has inspired you to further research and reflect on how science and technology can benefit humanity. Take care of yourselves and maintain your health so you can witness the implements of all these technologies in good spirits. Thank you.
Thank you very much, Alexander. Definitely, we are waiting for implementation of such technology. Of course, on the other hand, we have to also remember about ethical issues and disadvantages of implementation of such technologies. So thank you for this kind of review of the latest technology in healthcare, medicine, biotechnology. I have to say that I was overloaded with such huge amount of data, and I'm impressed. But actually,
I'm sorry. I wanted just to speaking about the main things,
great.
but the main things is in every topic.
The presentations we are going to record, and also they are recorded actually, and we are going to put to the to YouTube, for example. So our participants will have also opportunity to listen once again if something was too complex to understand, to catch it. But basically, you have painted a quite positive picture of the use of new technologies in this field, such as medicine, biotechnology, healthcare. And also, as I said, your presentation definitely also raises some questions, ethical concerns, especially in terms of implants or brain-computer interfaces, right? This is the very, very controversial issue. But now, because there is no room for questions, but we will have time for discussion during our upcoming discussion panel. But now it's time for, let's say, for a darker picture of innovation in medicine and biotechnology. I'm excited to introduce our next speaker, Professor Jennifer Huberman. Let me say a few words about Professor Huberman, professor of anthropology at the University of Missouri, Kansas City. Her recent research has explored the transhumanism movement in the United States and capitalism in the digital age. Currently, she is working on a new book that examines the fragility of friendship. But also, let me add that her book, Transhumanism from Ancestors to Avatars, has recently been published in Poland. Polish title is Transhumanizm od przodków do awatarów. And today, Professor Huberman will delve into such topic, the magic, science, and religion of pet cloning, and homage to Bronisław Malinowski. It's a unique blend of anthropology and modern science, reflecting on Malinowski legacy. So actually, there is a Polish thread inside. So welcome, Professor Huberman, to our forum, and our virtual floor is yours. Actually, our screen is yours.
Thank you. Okay, so to share my screen, can you see? You can't see my slides right now, right?
You can just press this button, this green one, and probably will appear.
Oh, the green, hold on, maybe. Can you see my slides?
No.
Oh.
Susanna, can you lift your
Hold on one sec.
Okay.
Okay, share screen.
Yes, exactly.
And
You
can
have
you see-
to, once again,
continue?
probably
Okay, here.
open
Here we go.
once again by pressing this. Oh, yes, exactly.
Great.
Okay, so now you can see it.
Yes, yes, yes.
Okay. So first, I would like to thank you, Conrad, for inviting me to speak. I am very excited to be here because my grandfather was from Poland, and I never imagined that I would have the opportunity to present my work at a Polish university. For those of you who are familiar or who are into classical music, I am related to Bronislaw Huberman, who was a famous Polish violinist. Somebody was just asking me about that yesterday. But I'm also excited to be here because I think that the questions that are being posed in these HumanTech meetings are incredibly interesting and incredibly important. How do we study the social and psychological impacts of new technologies? How are human beings using technologies, new technologies, to enrich their lives? How do new technologies stand to destabilize the boundaries between life and death? And in my research on the transhumanist movement, I have addressed some of these questions. For instance, I've written about transhumanist attempts to achieve immortality through the technology of mind cloning. Transhumanists believe that we will soon be able to clone our minds and live forever in avatar form. Today, I want to shift gears a bit, and I want to continue to explore how cloning is utilized as a technology of immortalization. But instead of focusing on transhumanist initiatives, I want to turn our attention to a more mainstream practice, and that is the cloning of pets. And let me emphasize that I realize the topic of pet cloning is probably very far afield from what other presenters have covered in these meetings, but my hope is that it might help us spark an interesting conversation nonetheless. So the title of my talk is The Magic, Science, and Religion of Pet Cloning, an homage to Bronislaw Malinowski. Most of you probably know this, but Bronislaw Malinowski was a very famous Polish anthropologist who ended up emigrating to England and was sort of known as the founder of modern fieldwork. I am going to read my talk, but I'll try to do so in an animated manner so you don't fall asleep. So, a quarter century ago, when a Scottish ewe named Dolly first appeared on the world stage, cloning was both celebrated as a revolutionary technoscientific breakthrough and lambasted as a blasphemous attempt by humans to play God. Indeed, the controversy surrounding the cloning of Dolly and the multiple debates it engendered is one of the reasons why anthropologists found Dolly so good to think with. The Dolly case invited anthropologists to consider how new forms of biotechnology are reconfiguring reproduction, kinship, and even conceptions of life itself. In the years since Dolly's debut, animal cloning has gone from a revolutionary scientific discovery to a mainstream commercial practice, frequently used to improve livestock herds or secure the genetic purity of a breed. In 2002, for instance, Blake Russell founded the biotech company Viagen. The company provides commercial bovine, equine, and porcine genetic preservation and cloning services, and it has emerged as a premier source of cloning technology for all non-primate species. As the company has grown, it has also diversified its offerings. In 2015, Viagen launched Viagen Pets, specifically to serve pet parents worldwide by providing them with genetic preservation and cloning services. For $50,000, pet parents can have their dogs or cats cloned, producing an offspring that is genetically identical to the original. As the website explains, and I quote them here, dog cloning through ViaGen Pets presents an opportunity for dog owners to extend their relationships with their beloved pets. Dogs provide a unique form of companionship, loyalty, and love. It is difficult for many dog owners to imagine life without their dog. Indeed, many dogs become a member of the family. At ViaGen Pets, many of us are loving dog owners ourselves, and we understand intimately the nature of these relationships. The company not only presents cloning as a viable way to continue a relationship with a deceased pet, it also suggests that pet cloning can offset feelings of grief and produce, quote, a love that will last forever. As the website advises, quote, the first step in dealing with pet loss is accepting that it's natural to experience strong feelings of love for your cat or for your dog. A second step is to consider pet cloning. ViaGen Pets can help you with meeting the challenge of losing a pet and continuing that relationship through pet cloning. While the company stops short of promising that the clone will provide an exact replica of the original pet's personality and demeanor, it does suggest that genetic inheritance is likely to produce a copy with many of the same key attributes. The website states, quote, we know that many dog owners have questions about cloning dogs. A cloned dog is simply a genetic twin of your dog born at a later date. The cloned twin will share many of the key attributes of your current dog, often including intelligence, temperament, and appearance. ViaGen's Chief Science Officer, Sean Walker, echoes this notion. In a 2020 interview, he explained, quote, it's the same genetic makeup, and genetics makes up all the characteristics of the animal. But what we don't know is how it affects behavior. I can say, however, that I've been overwhelmingly surprised at how much it appears behavior is controlled by genetics, based on the feedback we get from clients. Taking ViaGen Pets as a case study and drawing upon client testimonials, in this talk, I want to explore how pet owners imbue clones with scientific, religious, and magical significance. In so doing, I draw inspiration from an essay that was penned long before cloning ever existed, Bronislaw Malinowski's essay, Magic, Science, and Religion. While much of the work on cloning has been informed by more recent developments in science and technology studies, I hope to demonstrate that this seminal text, written almost 100 years ago, still has much to teach us about the social and psychological significance of clones. So before moving on to analyze the client testimonials, I want to briefly discuss Malinowski's essay, and perhaps some of you are familiar with it, but I will provide a recap. Published in 1925, Magic, Science, and Religion was first and foremost a critique of the evolutionary paradigm. In contrast to anthropologists such as James Frazer and Edward Tyler, Malinowski argued that magic, science, and religion do not reflect different stages of the social and psychological evolution of man. Rather, they respond to different human needs, and as such, they can and do exist together in any given society. Whereas Levi-Bruhl famously saw primitive man as ensconced in mystical thinking, Malinowski adamantly declared, and I quote him here, The view that primitive man has no rudiments of science, that he lives in a world of mystical or magical ideas, is not correct. No culture, however simple, could survive unless its techniques and devices, its weapons and economic pursuits were based on the sound appreciation of experience and on a logical formulation of its principles. Indeed, for Malinowski, human beings' capacities to engage the world from a scientific standpoint and use reason and rationality to grapple with the empirical world around them is precisely what has rendered human beings more adaptable than other species. Whereas science responds to the need to understand, master, and control the empirical world around us, Malinowski argued that magic stems from a profound recognition that human beings are not in full control. It's a way of, quote, ritualizing optimism when confronted with situations that stand to undermine or overwhelm human intentions. So the classic example that Malinowski used, that he drew from his fieldwork with the Trobriand Islanders, was that when the Trobriand Islanders would fish in the calm waters of the lagoon, they never invoked magic. But when they would venture out into the open and dangerous seas to go on longer fishing expeditions or intertrade island expeditions, they always invoked magic. Now, although Malinowski critiqued James Frazer for his evolutionary paradigm, he did praise Frazer for brilliantly describing and exhaustively documenting the nature of magical thinking. For Frazer, and Malinowski agreed with him on this point, magic could be described as a form of pseudoscience that works to achieve a particular end through a faulty understanding of the laws of cause and effect. Malinowski wrote, quote, "Sir James has shown that there exists a special lore of magical substances based on affinities, on ideas of similarity and contagion developed within a magical pseudoscience." So the classical example of this kind of magical efficacy or magical thinking that's based on ideas of similarity and contagion is the voodoo doll. The voodoo doll not only provides a likeness of the person to whom injurious effects are desired, but it also works because it contains a piece of the person in the constructed effigy. This might be hair clippings, nail clippings, or clothes. But the basic idea here is that what is done to the voodoo doll will be experienced by the person on whose likeness it is based. Now, to the extent that magical thinking is motivated by emotional needs, magic also shares an affinity with religion. Malinowski explained, quote, "Both magic and religion arise and function in situations of emotional stress." And for Malinowski, the fear of death was one of the main sources of religion. As he famously argued, and I'll quote him here, "Of all sources of religion, the supreme and final crisis of life, death, is of the greatest importance. Death and its denial immortality have always formed, as they form today, the most poignant of man's forebodings. And here, into this play of emotional forces, into this supreme dilemma of life and final death, religion steps in, selecting the positive creed, the comforting view, the culturally valuable belief in immortality, and in the continuance of life after death." So just to recap, for Malinowski, magic, science, and religion were not competing forms of knowledge and belief, but rather complementary ones that each responded to a respective set of human needs. What I hope to demonstrate now is that Malinowski's distinction between magic, science, and religion, and the respective needs they each fulfill, can be usefully applied to understand the phenomenon of pet cloning. However, I will also suggest that the world of pet cloning introduces some interesting differences in the way that magic, science, and religion operate in contemporary society. The ViaGen Pet website features more than 100 testimonials, or as the website refers to them, pet client stories. Almost all of the stories contain a photograph of the pet, a tribute to the animal, and some explanation for why the owner decided to have their pet cloned. The first point to note about these stories is that they are incredibly moving. I am not a dog or a cat person, but as I read through these accounts, the expressed feelings of love, loss, and gratitude brought me to tears several times. While some of the tributes feature pets who are still alive, most of them refer to cats or dogs who have already died and who have been or are currently in the process of being cloned. The pets are variously referred to as my baby, my child, my entire world, my soulmate, and even the love of my life. In other words, these testimonials make clear that in Western society, as many others have noted, pets are kin. They are regarded as beloved members of the family, and it is precisely through their abilities to make their owners or their pet parents feel recognized and understood that personhood is bestowed upon them. And I think this is an interesting point to think about because I think it raises some interesting questions about what are the conditions of possibility for human beings bestowing personhood on other non-human actors in the future. And maybe we can talk about that in the discussion. For instance, in a tribute to her dog Ella, a 4.5-pound Yorkie, one woman writes, "Ella is our entire world. The day I brought Ella home was one of the very best days of my life. The second I stepped within a few feet of her, she nearly leaped into my arms, like she had been waiting for her mama to find her." After describing Ella's sweet and intuitive nature, the woman explains, quote, "I know that I could never get this lucky again in a million years. This is why ViaGen was a no-brainer for my husband and I. We are not having children, so Ella is our baby, and imagining life without her is unfathomable. But we know that life is finite. At first, I thought the idea of cloning a dog was wild, but I must say that simply knowing we'll have an opportunity to get her back, or at least her twin sister, when it's time for her to leave us, gives us so much comfort. It makes even the thought of losing her feel so much less devastating." In a tribute devoted to her little Chihuahua Nika, another woman writes, quote, "People didn't invite me places. They invited me and Nika. She made my life so much better. She gave me a reason to keep going most days. This little Chihuahua protected me from bears while camping and other more vicious predators while walking at night. When I had a human child, I thought I would love my child more and Nika less, but it never felt like that. The love I have for her feels the same as the love I have for my son. So her loss has been as devastating as I imagine losing my child would be. Life will never be the same without her, but the knowledge that I will soon have her twin or nearly identical daughter, a piece of her, it does so much to assuage my grief and pain." Yet another example comes from a woman who posted a tribute to her dog Nicholas. She explains, quote, We met Nicholas during a fundraising event for dogs, and he captured our hearts from that very moment. He came to our home the following day, and the rest is history. He has a lovely personality, and he behaves like a human. Nicholas has truly changed our lives, and as he's growing older, we cannot even think of losing him or living without him. We decided to research cloning, and we feel it is the best way to keep him with us. The feelings expressed in these testimonials do make Malinowski's point that death and its denial, immortality, have always formed, as they form today, the most poignant of man's forebodings. And yet, while these remarks clearly display what might be considered a religious impulse, that is, a desire to transcend the finitude of death and maintain a connection with the deceased, they also prioritize science as the best way to do this. As Nicola's owner put it, we decided to research cloning, and we feel it is the best way to keep him with us. Or as Layla's mother put it, quote, Layla was for me a best friend, companion, hangout buddy, relaxing partner. She brought so much joy and so little stress to my life. I know I will never be able to find that in another dog. That's why cloning makes so much sense for me. I'll see Layla again, and it's not some wishful after we die we meet again in heaven situation, but rather the factual occurrence of cloning her. I look forward to that day. The attempt to turn immortality into a techno-scientific fact rather than a religious endeavor is hardly limited to the world of pet cloning. As Abu Farman makes clear in his fascinating book On Not Dying, Secular Immortality in the Age of Technoscience, immortality projects have not only become, quote, a plausible part of the general techno-scientific imaginary, they are also now squarely part of Silicon Valley's cartography of power. The promise of using science and technology to render beloved pets immortal may be gaining quicker traction than initiatives centered on humans, but such efforts, particularly in transhumanist circles, as I noted earlier, are clearly underway. Moreover, both kinds of initiatives speak a changing division of labor in society, in which increasingly it is science rather than religion that is being called upon to counter the foreboding dilemma that Malinowski was so concerned with. In this regard, we might ask, to what extent has the science of cloning subsumed a religious function? In a society where pet deaths often go unremarked, does the science, or rather service of cloning, provide pet owners with a way to ritualize and honor the death of a beloved pet? While pet cloning clearly reveals a religious desire to immortalize a pet and maintain a continuing relationship with them, it is less clear how this process is facilitated and understood. How exactly does cloning provide a means to secure continuing bonds with a deceased pet? In what terms is cloning understood as a technology of immortalization? How is the continuing bond between owner and pet forged not only through the science of cloning and the genetic replication it makes possible, but also through the imaginative capacities and meaningful connections that pet owners bring to the cloning process? It is to these questions that I now turn. From the company's perspective, what is rendered immortal in the cloning process is the genetic identity or profile of the pet. Cells are immortalized through the technology of culturing, Explaining how this process works, they write, quote, "The first step in having the option to clone your dog is to preserve your dog's genes through genetic preservation. Your veterinarian will collect a small tissue sample from your dog. This process is a minor procedure. That tissue sample will then be mailed to ViaGen Pets, where we will culture new cells that share the same genetic makeup. We will then freeze these cells until you're ready to clone your dog." As noted earlier, the company suggests that genetic replication will entail a replication of other key attributes, such as the pet's temperament, appearance, and possibly even behavior. And yet, for many pet owners, the importance of retaining the genetic profile of their deceased pet does not seem to lie in the idea that it will generate a clone with the exact same personality or behavior. Indeed, most pet owners emphasize how utterly unique and irreplaceable their pets are. For instance, describing her dog Peanut, a woman remarks, quote, "Peanut was one of a kind and can never be replaced. I know she'll be waiting for me in heaven. But now that I'm working with ViaGen, I'm hopeful Peanut's clone will be close to her." Thus, what seems to matter most to pet owners is having an actual piece or part of their pet live on and being able to re-encounter that pet's image in the face of the clone. For instance, Lily's owner explains, quote, "I've never had such a close bond with a dog, so I decided to have Lily's genetic information preserved. While there's no replacing her, it still brings me great comfort that there will be a part of her that will continue to live on in her future clone." Herbie's owner expresses a similar sentiment. She writes, quote, "We've been blessed with many dogs over the years, all rescues. Each is special and unique, and those who have passed on are missed beyond words. As Herbie, who's one of our last surviving companions, nears the end of his life, we realize that we want to be able to keep a part of him with us. We became aware of ViaGen's cloning service and felt like this was something we really wanted to do." Jeremy Bentham's owner further emphasizes the critical importance of being able to encounter the face of his dog in a clone. He states, quote, "If my boy Jeremy Bentham was a golden retriever, I'd probably just get a golden. If he was a Great Dane, I'd be buying those huge goofy guys every 10 years or so. But Jeremy Bentham is a mutt. All I know is I'd love to see a face that reminds me of my best friend someday. I know that until then, I'll be subconsciously looking for him in the faces of other dogs. Call it an homage. I'm looking forward to having the opportunity to do so through cloning." Similarly, Wolfsbane's owner also reflected upon the importance of being able to behold the image of her deceased dog. She writes, quote, "Wolfie was born with severe subaortic stenosis and developed heart failure at only 8 months old. He passed away 1 month after his 3rd birthday. I was his foster parents since he was 6 weeks old, and we were only apart for 1 day since he came to my house. I officially adopted him at 5 months old. He's my special boy, my baby. I love him with all my heart, and I believe he loves me as well. I understand that his clone won't be him, but all I want is just to see him, his physical form, hold him and kiss him one more time." Finally, reflecting on her desire to clone her cat Bits, another pet owner writes, quote, "I know that Bits is not a collection of cells. that she is every bit as much as a product of nearly 2 decades of love and interaction with us and the world around her as she is her DNA. I know that genetically preserving her is not a way to bottle those experiences and revisit them on command. That would diminish their magic. I know you can't clone a soul, and hers was far too unique to even imagine doing so. But what Viagen and their incredibly compassionate staff offers is an ability to intertwine the moments you've cherished so much in a familiar face with a new set of memories that will carry you into the future. While Bit's owner is concerned with preserving the magic of her experiences with her former cat, I want to propose that all of these narratives manifest a classical form of magical thinking. In all of these accounts, we find that the efficacy of the clone is predicated upon establishing relations of similarity and contiguity with the original pet. James Frazer famously proposed that these two principles constitute the basis of magical thinking. The first, he wrote, may be called the law of similarity, and the second, the law of contact or contagion. Frazer wrote, quote, "From the first of these principles, the magician infers that he can produce any effect he desires merely by imitating it. From the second, he infers that whatever he does to a material object will affect equally the person with whom the object was once in contact, whether it formed part of his body or not." Right? Here's the efficacy of the voodoo doll that I talked about earlier. Although Frazer conceived of magic as a pseudoscience that reflected the faulty reasoning of primitive people who misunderstood the laws of cause and effect, the anthropological record clearly demonstrates that such magical thinking lives on in contemporary life. Indeed, I am proposing that although pet owners themselves may not be able to articulate it in such terms, magical thinking, it can be detected in the various ways they attribute significance to the clone. If the peoples Frazer wrote about thought they could injure their enemies by destroying an image of them, pet owners seek to transmit love to the original pet by embracing the clone. By casting their love upon a clone who bears the same image and possesses the same genetic profile as their deceased pet, they find a powerful way to continue the bond. Thus, although clones are initially produced in a scientific laboratory, I argue that they are only completed in and through the magical thinking of their pet owners. By bringing these principles to bear on the relationship with their clones, pet owners find ways to magically preserve their relationships with their deceased pets. Clones, therefore, may be more usefully conceptualized as living effigies that work to continue a relationship with a deceased pet rather than viewed as replacements for them. Indeed, many of these testimonials suggest that trying to replace a pet would almost be as blasphemous as trying to replace a child. As Lexi's mother writes, quote, "Lexi was an incredible dog, loving and sweet. She was so gentle and kind to everyone she met. Lexi is one of a kind. She was always by my side wherever I was, and had the best personality. Never ever did she disobey me or any of the family members in the household. She did things that I have never taught her and was the most well-behaved dog ever. I can't imagine life without her, but sadly, she passed away due to a heart condition known to her breed. I don't think I would ever want to replace her, but knowing that there's a service that can replicate her will mean so much to me and my family just to be able to see her again. So here again, we find that the desire to clone is not about replacing Lexi, but rather it's conceived as an effective way to maintain a relationship with her. By cultivating a relationship with the replica clone who bears an uncanny resemblance to Lexi, and by containing part of her genetic profile, this bereft mother will be able to preserve a connection with her deceased pet and thereby actualize the promise that Via Gen Pets Company promotes, which is, quote, producing a love that will last forever. So, to wrap things up, Malinowski's essay, Magic, Science, and Religion, was written well before cloning had ever emerged in the world as a techno-scientific possibility in practice. Indeed, some might find the desire to return to his essay as counterintuitive, if not counterproductive. However, what I've hoped to demonstrate is that this century-old text still provides some useful and perhaps paradoxically new perspectives on the phenomenon of pet cloning. In concluding this talk, therefore, I'd like to discuss what I think this exercise has taught us. The first lesson to be gleaned is that from an anthropological perspective, cloning emerges as a fascinating topic of inquiry, not only because it enables us to question how new technologies are reconfiguring conceptions of reproduction, kinship, and life itself, nor because it helps us better understand the way technological developments take on different forms of cultural and political significance. These questions have been explored with great insight and dexterity in the anthropological literature. However, by bringing Malinowski's essay to bear on the topic, we arrive at a new set of questions about the way that pet cloning speaks to pet owners' psychological needs. As we have seen, the love bestowed upon pets makes their deaths absolutely devastating. And this engenders a powerful impulse to counter the finitude of death with dreams of immortality. Though it might be going too far to describe pet cloning as a form of religious practice, if we follow Malinowski, the impulse that animates this practice can certainly be thought of in such terms. The second lesson this case study imparts is that the respective psychological needs Malinowski associated with magic, science, and religion have not abated. However, what has changed is the way they are attended to. This case study suggests that the division of labor between magic, science, and religion is indeed shifting. As immortality becomes a techno-scientific project, science and technology are increasingly coming to assume a function that was once dominated by religion. And again, this is a point that Abu Farman makes in his fascinating ethnography of human immortality initiatives. He proposes that techno-scientific immortality initiatives provide a privileged window from which to explore the tensions inherent in the age of secularism. And in many respects, Farman is correct in proposing that such initiatives do bespeak a more secular worldview. However, what Malinowski's work enables us to appreciate, at least when applied to the issue of pet cloning, is that even if science is being entrusted to solve the problem of death and realize the promise of immortality, there is still something quasi-religious and even magical about the way all of this works for pet owners. Indeed, to my mind, the most interesting point to be gleaned from this analysis pertains to the way magical thinking is invoked by pet owners. While pet owners place their faith in science to deliver the clone, the efficacy of the clone is only secured in and through the magical thinking they bring to the process. For pet owners, it is not the science of genetic replication that is most persuasive, but rather the ability of cloning science to produce a copy who bears both a striking resemblance to the original pet and who contains a piece or part of them. In this respect, I have argued that pet owners do put stock in the principles of sympathetic magic, and that clones might be better conceptualized as living effigies rather than as replacements. As Malinowski reminds us, quote, "The theories of knowledge that animate magic are not dictated by logic, but rather desire. And the ultimate desire that pet owners express is to maintain continuing bonds with their beloved pets." Thank you. That's it.
Thank you very much, Jennifer, especially for reminding us about Bronisław Malinowski, famous Polish anthropologist. It was, in my opinion, great compliment to what Alexander was talking about in terms of pushing the boundaries in biotech, right? And also you mentioned some animals, and of course, I'm sure that most people here miss their pets and that have passed away. But it's of course a question about whether cloning is the solution. And of course, we have to understand people's desires, needs. However, as Asia wrote, it's tempting but selfish. And probably we will talk about such concerns during our upcoming panel. But of course, also what surprised me was the fact that you have Polish roots. It's amazing, big surprise for me. Okay, now I would like to hand over a comment of the rest of the meeting, our meeting, to Michał Matecki from Brainstorm company. So Michał, can you introduce our panelist? Thank you.
Thank you, Konrad. I'm pleased to moderate this panel today with distinguished guests. My name is Michał Matecki. I represent Brainstorm as an international expansion strategist for medtech companies that want to enter Polish healthcare market with their innovations. Let me introduce our other guests today who are joining the panel. Joanna Andrusiewicz, bioethicist from the University of Warsaw. She's focused on the ethical aspects of human and non-human relations. And a warm welcome to Jakub Zawiła-Niedźwiecki, a philosopher and bioethicist also from the University of Warsaw. Before we start, I encourage you, our audience, to share their questions over the chat. And now I want to turn to our panelists. Would you like to comment on what we've just had a chance to listen to? Joanna, please.
Thank you. Yes, Jennifer, thank you so much for bringing this subject. As I saw, a lot of, or at least a huge part of our participants were really into it. And what I would like to add is that this is a very, very important part of your presentation for me from the ethical point of view, is that there is a huge difference between thinking about this new cloned animal as a replacement and as a new being who is carrying a part of this beloved one. And at the same time, as one of the participants highlighted, there is this problem of high expectations at the very beginning of the of this new life. So I think it could be ethically problematical, at least. But the other thing, and this is what I would like to ask you, is I know we have a international consensus that we are not cloning humans, but you know, philosophers love thought experiments. So I would like to ask you, and to ask also other participants, do they think there is a real important distinction between between keeping a part of our beloved one if he or she is a human in this way, and between keeping a part of our beloved non-human animal, if it would be possible, just like a little thought experiment, if it was, for example, our beloved ferret and or a dog and our beloved grandfather. Thank you.
Should I respond to that?
Yes, please.
Okay, sure. So, so yeah, I mean, the transhumanists are arguing that we are going to be able to clone humans through the technology of mind cloning. And to me, as an anthropologist, what interests me is not so much the ethical issues surrounding cloning, whether it be in relationship to pets or in relationship to humans. But what I'm trying to do in this talk, and what I've tried to do in my earlier writing on mind cloning initiatives, is to demonstrate that even though we speak as if it's just a technological issue to be conquered, right? It's just about the science of cloning that will deliver a cloned pet or a cloned human, that there's always a symbolic maneuver that human beings have to perform in order for the clone to be compelling. So for instance, if you look at the transhumanists and their discussions of mind cloning initiatives, for them, the whole initiative is predicated upon the idea that we conceptualize the essence of the person as a mind, and that the mind itself is nothing other than a set of information, right? A code. And it's because mind is code, mind is information, that we will be able to transplant our minds onto a different kind of substrate, right? To my mind, as an anthropologist, what makes that kind of thinking interesting is that on the one hand, it seems so different from the way that people have thought about immortality from a religious perspective throughout much of human history. But it's really not that different. How different is it to then saying, well, the essence of a person is a soul, and the soul can live on in this other world. So to me, that's what I am continually fascinated by. I mean, I can barely operate my cell phone. I'm not into technology, but it's how these kinds of initiatives that seem very new, that seem very modern, that seem cutting edge, are actually similar to ways in which human beings have been grappling with these issues for thousands of years.
So our new magic and our new rituals.
Yes.
Thank you.
So then Magdalena Gabryś wrote over the chat, isn't grief a part of relationship? Isn't a perspective of a fear of losing one, in that case an animal, makes us cherish moments together?
Yes, I think this was also kind of Heidegger's point that, you know, death is the horizon against which life becomes meaningful and human relationships become meaningful. But I think that we also know, again, looking at many societies across time and space, that human beings, or even if we go back to the work of Robert Hertz, you know, a wonderful French sociologist, nephew of Emile Durkheim, who wrote about mortuary rituals and why human beings require them. And he said, it's too much for us to accept the reality that one day someone we love who is full of life, the next day is gone. And so we find cross-culturally all sorts of interesting ways in which human beings try to symbolically and ritually attend to grief. And part of what I'm suggesting in this talk today is that maybe cloning is the new ritual that we are turning to try and address the grief that we experience when we lose a pet. I mean, if a child dies, we have a funeral. It's far less common for people, although it's not completely uncommon. People do sometimes have funeral for their pets, but it's not as ritually celebrated and marked. And so one of the things I'm curious about is, to what extent does the science of cloning work to try and help people process their grief and also ritualize the death of a pet?
So we can use technology in situations when our mind struggles to understand or accept any situation. So to create the magic. Yeah. Thank you. Jakub, would you like to elaborate on this a bit?
Yes. Well, the two things are striking for me. First of all, how magical is this thinking, and on both sides, the so-called transhumanists and the people who want to clone their pets, because this is not how actual neuroscientists think about how minds work, right? I mean, in philosophy of mind, we would say that this kind of dualism is just ancient. Basically, it's outdated completely, and something more modern includes both embodiment, and you have embodied minds and kind of thinking bodies, or something like that. So this is very interesting, how people who are supposedly so connected to technology are so kind of outdated in their thinking, in a sense. That's one thing that's very interesting for me. But the second thing I wanted to point out, I was hoping that Joanna would mention this, but I think this is something we must mention here, is that it's very strange that people who care so much about their pets or their close ones treat them in such a like things, basically. Like you can have a new one and treat it as a replacement. So it's almost like a commodity, and this is this whole promotion of this idea is, for me, is quite shocking, that those new clones don't have their personalities of their own, or the kind of life of their own. In this anthropological approach that you presented, somehow they become like symbols, but not living beings with their emotions and feelings and everything. And this is something that's completely, for me, kind of scary, when we think about that we could go to humans and have replacement humans that are kind of supposed to behave like their previous genetic templates or something like that. They are supposed to have certain traits and so on. It's kind of problematic, and this kind of symbolic life extension in humans would be something very scary, even though I think it's scary in pets already. Even if somebody doesn't kind of subscribe to full agency for animals like dogs or cats, even then this is scary. If you subscribe to like at least some agency for them, then it becomes much more problematic.
Mm-hmm. Jenny, would you like to comment on this?
Okay, sure. Yeah, thank you. First of all, I completely agree with your comment about the transhumanist conceptions of mind and how they leave out the body and all of those things. I guess from an anthropological perspective, my interest has never really been in sort of interrogating the veracity of their scientific claims, but rather understanding the kinds of assumptions that they make that would enable them to propose that mind cloning could be possible. I think that if we had, neuroscientists in the room looking at the claims that they're making and the way that they conceive of the mind, and the mind is disembodied, there would be a lot of debate, right? Second, I really appreciate your point about why this pet cloning could be disturbing, and how it sort of presupposes almost this willingness to be able to commodify a pet that you at the same time claim to love and think is this unique, wonderful, special animal. But what I would also say is that this is one of the reasons why I think it's an interesting topic to focus on. At first glance, I came up with the idea for this topic and I was like, this is ridiculous. Who wants to hear about pet cloning? This is so silly. But to your point, I actually think that it gives us an opportunity to anticipate what debates around a possible future human cloning might look like. And I think that because this is becoming mainstream much more quickly than initiatives geared towards human beings, that all of us anthropologists, bioethicists, should be paying close attention to what's going on. The other thing I would say is that my sense, and I didn't talk about this in my discussion today, but it's something I've been thinking about, again, gets back to the difference between a willingness to clone one's pet versus a child. And there's a part of me that thinks that the desire to clone a pet is not just about a way to attend to the grief of losing a pet, but it's also a way to attend to people's death anxiety. That pets live for 10 years, 15 years, right? And so you come to measure your life in a certain sense through the lives of the pets you've had. I have a crazy Uncle Richie who has had a dog named Char. He's gotten 4 more of those same dogs, Char 1, Char 2, Char 3, Char 4. He names them the same. And when I look at that, what I see is an attempt for him to rage against the reality of death. And seeing his reflection, I mean, could have a whole discussion about the way that pets operate as self-objects if we wanted to take a psychoanalytic spin on things. But what I see him doing when he gets the same dog, time after time after time again with the same name, I see him fighting against his own mortality, if that makes any sense.
Yes. Thank you, Jenny. I'd like to pivot for a while to Alexander. Alexander.
Yeah, but sorry for
Yes.
interruption, but I see that Joanna is raising her hand.
Oh yes, please. Sorry.
Okay, so maybe.
Thank you.
Thank you very much, Konrad, and thank you. Thank you for giving me the voice. I would like to comment what Jakub said, because maybe my assumption was wrong, but from what I heard from Jennifer's presentation was the love and the hope and the grief of those people. And when Jennifer told us about this crazy uncle, that was the kind of objectification of animals, of non-human animals, that Jakub mentioned. But what I heard before was a lot of love and hopes, and I really didn't think about it as an objectification of animals. I thought it was useless, it was pointless, because it is some kind of delusion that we in a biological manner we are keeping a part of this pet, but it is maybe it is more more selfish to clone one's pet than to it is probably more selfish to clone one's pet than to adopt from a shelter, but I don't think it is objectifying them, not in a way I am thinking about objectification of animals. We see in case of a lot of practices we are using towards animals, like we use them for food, we use them in experiments, we use them for clothing, etc., etc. So it was not the case for me, but maybe Alexander could verify one thing for me, because I know when we face the case of cloning, we have also some problems with possible biological outcomes, like shortening of telomeres and things like that. So maybe this is the aspect of cloning which is leaning towards objectification of animals. Alexander, could you help me?
Yes, there was some problems like the loss of telomeres in the first clones, and also was speaking that the clone, for example, of the dolly sheep was problems with ankles, with different joints and other. But then it was understandable that the problems of in the joints was from the perspective of the life conditions of such animals, because they live in the another conditions, neither the dolly itself, and but from other perspective, questions with telomeres nowadays have a solution, because we got not one tactics of cloning, but different operations for this. And for example, even I think 4 or 5 years ago, there was first cloning of primates, monkeys in the China, and there was all different new cloning tactics to achieve this. So, but yes, we should to understand that there is some consequences, and cloning it's not so simple idea that we can clone the human tomorrow or something like this.
Thank you. Alexander, you have shown us a cross-section of the advanced technologies that are being developed. Perhaps some of us are not even aware of how many futuristic projects in medicine are already advanced, and how they can change our lives very soon. And it's not just AI that is buzzword now, but in context of your involvement with the Proven Reality project and your recent co-authored publication on VR for children with spectrum of disorders, what key challenges do you face in integrating VR into daily therapy and adopting this technology in general for medical purposes?
Okay, thank you for your question. Yes, indeed, we are working with some specialists, therapeutists who are working with children with psychoneurological disorders, and we're applying the virtual reality as a tool of the treatment. Once again, virtual reality, it's not the universal treatment options, it's just a tool, and in the good hands of good specialists, it can be a very useful tool. I want to write if there is 1 hour sessions per therapist with child, the virtual reality sessions is only 5 or 10 minutes, not more, but it's enough. The main challenges, it's not even from the position of child or parents, because parents are happy when they see new technologies in working with the child. Childs, of course, especially childs with autistic spectrum disorders, they're a little bit afraid of this headset and other, but we made the guidelines how in playful manners, like a game, start to use it. But the main challenges, it's from the perspective on some conservatory views of the specialists who are decades working with one program with the child and don't know how to implement these new technologies in the practice. And also convincing the different centers in Poland, what I am doing right now, and specialists to adopt the virtual reality methodologies had been challenging. But initial resistance usually gives way to enthusiasm when the innovation upon experiencing VR for first time, when they just one time looking at this tool and understand what it is, that it's not just some game or something like this, but it's a good tool. Then most of the specialists agreed that it can be very helpful. And of course, it's very good that we can adopt to any child the environment, virtual reality, and all that we need.
Do you envision VR becoming a standard soon in broader medical fields, not only this?
It's hardly to say, because yes, in some fields it's very helpful. For example, in rehabilitation, I didn't speak a lot about it, but there are some researches that showing that people with much more desires after strokes or after injuries make a rehabilitation in gamification manner, where they need not just raise up their hands, but took some virtual objects or virtual fruits and give to some virtual creature, something like this. And I even see some interesting applications when people are trained to control the newest prosthesis with the help of virtual reality. In virtual reality, they train their muscles and in the empathy limb how to contract something, and in virtual reality they much easier and in interesting gamification manner can control this virtual prosthesis, and then in real life they much more easier control this new prosthesis. So I think in rehabilitation it will be pretty soon. In surgery, by the way, when I speak about these surgery robots, the surgeons who operate on them, they see it on the glasses in the virtual reality, you can say it already implemented. But in other fields, I think it will be faster going to the psychology treatment of different psychology disorders and to the educational field.
Let me ask you one question I noted before from our audience. Maya Ben is asking, will extending life also go hand in hand with increasing quality of life?
I think it's very important question, but quality of life, it's not so linked with all these therapeutical techniques, and it's very cross-disciplinary questions where we should involve already now we should involve the some people who make decisions in how we live in the cities, in the countries, because when we face it in 10, 20, 50 years, we need the answers how to raise quality of life, because it can be many questions. But I believe that yes, that dedicated persons will find the good options how to improve the quality of life in any conditions.
Yes. Joanna, we are aware that some of innovations that Alexander mentioned before involve clinical trials on animals, such as Neuralink, for example. What is your comment on this? In light of the advancements in medical technologies that promise extending human life, how do you see ethical boundaries evolving between live beings like humans and non-human animals? A question to Joanna, please.
Thank you for this question. I can say I think it could go in different directions. First one is maybe the most probable. It is this that we are going farther and farther in separating our better moral status of humans. So we are the ones who make those really, really amazing discoveries. We are doing research, and now we are humans plus, you know. The moral status of animals and our treatment of animals is degrading and degrading and degrading. But on the other hand, it could go in a different direction, because maybe some of those technologies will be within the reach of only some humans, those who have resources like money. And this would mean that we could have, for example, new moral boundaries. We can have humans plus, and non-human animals, maybe separated in a few new categories. So I think both pathways are quite probable. I don't know how the rest of panelists think which one is more likely to come, but it could go at least in those two directions, and maybe in even more. And I think that there is also this danger that we will, when we could live longer and be healthier for a long time, we could value human life even more, and it could reinforce some non-humane species even attitudes towards animals. So on the one hand, this is so tempting, but on the other, I think we should be aware, and as Jennifer said, we can think before about those possible outcomes, the good ones, the bad ones, and the ugly ones, and discuss them now. Thanks.
Jakub, the pursuit of longevity, what ethical considerations should guide us, in your opinion?
Pursuit of longevity. Well, I see a couple of problems with that. There is, of course, like the general idea has been floated for hundreds of years that people, you know, that it would be, some people would say it would be great, and some people say like the life would not be worth living past some age because you wouldn't experience anything new. I wouldn't like to talk about that because it's too, let's say, distanced from what we're talking about today. But what I'm thinking about the most when I was thinking about this topic of this panel, I was thinking about this culture clash between two let's say areas, one coming from the tech industry and the other coming from biomedical research. So in biomedical research, traditionally, you have this kind of slow development, improvements, and you have at least since 1940s, you have all those ethical and legal regulations, very strict and so on. And then you have this culture of disruption. You have people coming from tech industry, people coming from biohacking and such areas who kind of want to disrupt everything, have this jump in technology, kind of throw in everything. And I think that this is a huge challenge from both, let's say, bioethical point of view, but also I can change my cap, so to say. I also kind of done some work in management, and it's also kind of culture and management culture problem, because you have those two types of thinking that in the same place, and it's very hard to kind of make them mesh together. And I think this is potentially can be catastrophic, can be kind of there are some opportunities in this. I think that there might be, but it will be very challenging to make this work in a good way. And what I'm worried as a bioethicist is that all kinds of IRBs or research ethics committees, depending on which side of the ocean we are not prepared for this kind of problem. Like, if they are approached by research projects regarding some disruptive technologies, they might not see them in a correct kind of way and understand what they're about. So this is something that's very kind of I see as a problem in general with the research cultures. And one more thing I wanted to add, because this is something I think is very important to mention today, is a problem that has been growing over the last couple of years with kind of life-enhancing implantable technologies, especially problem that's kind of connected to how our economies work, basically. The problem of long-term support for this kind of technologies. The good example that you might have heard of is the vision prosthesis devices, that basically the company went out of business and people lost their eyesight because there is no support for it anymore. And this is something that will happen as well with some, let's say, nano robots or things like that, where you will have some startup that comes up with something great. It actually works, but for some reasons, regulatory or business or whatever, they cannot continue in this business. And then what? And who is responsible for that? Governments, some international bodies. Who actually is responsible for sorting those problems? So this is a problem for having a regulation that doesn't stop innovation, at the same time makes it, let's say, basically responsible, at least in a minimal sense. And it's very, very hard because, as I said before, the culture of, let's say, bioethicists and people who are used to kind of talking about this kind of regulation, so let's say bio law people, want to be kind of easily adapted to this kind of new technologies. So there's a lot of problems, and we will be kind of walking into this minefield. And I think we will see more mines in the future than we see now, and it will be more and more of them.
Maybe Alexandre, would you like to comment the statement representing technology area?
No, I totally agree that there are a bunch of different bioethical problems that we need to solve, and we need to speak about it right now. One of the interesting that Joanna mentioned is affordability of such technologies. For example, if in the nearest time there will be some new neuro interface or something, who can afford it? Of course, from first perspective, it will be for very wellness people. But as I see for different even or pharmaceutical perspective or for technological perspective, nowadays we need 2 or 3 years to make the copy. Maybe at first it will be not so brilliant copy, but in a couple of years it became better and better. And for example, the Chinese nowadays make a copy of the brilliant robots like Boston Dynamics robot in 1 year who can make all the same things. And some biohackers group now analyzing the spectrum of different novel drugs and make the replica of these drugs that on biochemically is identical to these drugs. That's why I think if there will be some disruptive technology, it won't be forever with just the wellness people if they want just not sharing it with anybody. Because if the example of this drug, or if this technology will come to the dedicated persons with good knowledge in biochemistry or technology, we can make a replica of this. That's why I don't think that it's the very crucial problem. But what about the another problem? It's I don't have answer nowadays, and we need to discuss it more, of course.
Yes, thank you, thank you. Jennifer, would you like to take your point of view on this discussion?
Sure. I mean, I agree with what Jakub was saying, that I think, and I really appreciate the sort of two cultures point that he made, and the rapidity with which these, I mean, you can call it disruptive technologies. I think the people in Silicon Valley would say innovative. Innovation is an ideologically loaded word for plowing straight ahead with changes that stand to affect millions of people's lives without any kind of weigh in from larger governing bodies or citizens. There's actually, I don't know if you've read Jason Sadowski's book, Too Smart, which is about how digital capitalism is taking over the world. But this is a lot of what he talks about, and it's a wonderful book. And I think that it is a challenge, and I think that it does, we as a society have to have some more robust conversations about, do we feel comfortable letting these tech giants in places like Silicon Valley sort of steam ahead and try and convince all of us that these are the innovations that are going to make our lives better, we're going to live longer, it's going to, enhance our existence, without really slowing things down a little bit to ask, what are the implications of this? Or as Jakub was saying, what happens when you've, outsourced your eyesight to another platform and the company that started it goes down the tube? So they're complicated. And I think that's why these HumanTech meetings are important. But I am going to have to go because I have to teach my class. I missed
Okay,
the
of course
first one,
we
but I have to
understand
go
it.
to the
So
second one. But thank you, everybody. It was
thank
such
you very much. It was pleasure
you.
having you here. So enjoy your day, enjoy your class, and I hope see you in future.
All right. Have a wonderful discussion.
Yeah, thanks so much.
Thank you very much. Thank you. Yes, so Konrad, I can see that we are running out of the time, but
Yes. Exactly. So, of course, if there are some new questions or comments, or maybe someone wants to add something to our discussion, so free to do it. If not, of course, we will around to close our meeting, but let's say last chance to add something to contribute to our discussion. So
I just want to share with one interesting idea also that I didn't mention during the lecture, that nowadays I saw not only the involved was and even involved in some startups who working in reproducing the physiology of biochemistry, but some startups trying to analyze all the parameters of the brain, emotion in the non-stop time and make some generative AI, but consciousness and emotional AI. And I think it's also a very interesting topic, because they not only copy all the messages from the persons, like making another companies and making digital twin, but also seeing the electroencephalogram, what making or its emotion faces. And from my perspective, also what direction we can see in the nearest decades, it's the understanding of the nature of consciousness, because I think it's one of the greatest secrets that maybe some days we will find the answer on that question.
So,
Yes,
maybe
exactly.
a short wrap-up by Joanna and Jakub, just to finish the discussion, and then Konrad, please introduce the other events upcoming.
Yeah. So as I paste into chat space information, it's the unofficial actually information about our upcoming event. So at the end of the, as you can see, March, we will have another meeting, and to some extent, I think it will be continuation of our today's meeting, because we are going to talk about cyborgization, cyborgs among us, ethics, identity, and future of human evolution. So I'm really excited about this event, and I think you will be satisfied, because we also plan to touch some ethical concerns, and Rebecca Gibson and also Alexandra Łukasiewicz Alcaraz, they both wrote, published books, interesting books regarding cyborgization, this kind of process of cyborgization and post-humanism. So I expect an interesting discussion. So stay tuned, and I really encourage you to follow our channels, our social media channels, because we inform about our conferences and about our meetings. So as I said, now it's only this kind of poster, but in the next upcoming days you will see more details on our website, SWPS University, and also HumanTech Center. And also we would like to ask you to fulfill our questionnaire, short questionnaire about our today's event, and about your expectations regarding next events. For us, it's great to have kind of feedback and to improve maybe something, and maybe if you have some ideas, what kind of new topics should we introduce, should we elaborate, so it will be nice to know what you think about that. So thank you in advance for that, and thank you all of you for your time. For me was great pleasure to listen and to participate in this event. And of course, there are lots of because there's ongoing debate. It's so hard to find answers, right? We have a lot of questions. We see a lot of dilemmas. However, there are a lot of problems. A lot of still we are searching for solutions, right? And answer. What can we do in order to take into account our people's needs, right? And also psychological needs, because, for example, in terms of cloning, there are lots of also psychological problems related to, for example, missing our pets, right? Sometimes for people it's so hard to live without their pets. So there are lots of problems. So that's why, as I said, we have also plans to continue and to analyze this problem of human evolution, and also related to technological progress, right? Because it's everything about technology, about technological changes and emerging technologies. So please follow our channels and stay tuned. Thank you very much, and have a nice evening, the rest of evening. Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Have a nice evening. Take
Thank
care.
you, my pleasure. Thank you. Bye-bye.
Thanks.